You need to watch this if you struggle with understanding the life cycle of a star. From birth to a cosmic explosion, let's break it down. It all begins in vast clouds of gas and dust called nebulas. Gravity pulls hydrogen gas together until it ignites, marking the birth of a star. In its main phase, the star burns hydrogen in its core, generating energy for billions of years depending on its size. This is its stable, shining period. As it ages, the hydrogen runs out, and the star starts burning heavier elements like helium. This often turns it into a red giant, swelling dramatically. Finally, the end's smaller stars, like our sun, shrink into white dwarfs. But the big ones? They go out with a bang as a supernova, leaving behind a neutron star or a black hole. A star's life is ruled by its mass. The bigger it is, the faster it lives and dies, and that's a star's journey from birth to supernova. Keep looking up and stay curious, space enthusiasts.
If you don't like drifting off into space but still love planets, then listen up. Imagine space-time as a giant rubber sheet. Now, toss a heavy ball, like the sun, onto that sheet. See how it makes a dent? That's like how massive objects warp space-time. Now roll a smaller ball, like Earth, near that dent. It spirals towards the heavy ball. That's gravity in action. Einstein's general relativity says gravity isn't some invisible force. It's the result of this space-time warping. So, when you feel gravity pulling you down, it's actually space-time curving around you. Still with me? Great! Next time you look up at the stars, remember, they're all rolling around on this cosmic rubber sheet, and that's how gravity really works. Thanks, Einstein.
Exposing the secrets in your pocket. How does a simple compass guide you north? Let's find out. A compass is a simple tool with a big job. It helps you find directions using Earth's magnetic field. Here's how it works. First, it has a magnetic needle that spins freely. One end always points north, the other south. Why? Because of Earth's own magnetic field. Earth acts like a giant magnet, stretching from its magnetic north pole to its magnetic south pole. The needle aligns with this field. So when you hold the compass flat, the needle points to the magnetic north. Easy, right? Then there's the compass rose. That's the dial with north, east, south, and west marked on it. As the needle points north, you can see where the other directions lie, just like magic. So next time you're lost, remember, a tiny compass can show you the way. Cool, huh? Stay curious.
Why do scientists get so excited about black holes? Because they're the universe's ultimate mystery. Picture this. A black hole is a region in space where gravity is so strong, nothing can escape, not even light. How does that happen? When a massive star reaches the end of its life, it explodes and collapses into a tiny, dense point. This point is called where density is infinite. Surrounding this singularity is an invisible boundary. Cross it and there's no turning back. Black holes gobble up everything that comes too close, making them fascinating and mysterious. Imagine entire stars, planets, even light getting swallowed up. So next time you gaze at the night sky, remember, out there, black holes are hiding secrets of the universe. How cool is that?
Am I the only one that didn't know light has a cosmic speed limit? Buckle up, science fans, we're diving into Einstein's brain. In a nutshell, Albert Einstein's special theory of relativity sets the speed of light as the ultimate speed limit. Here's how it works. As an object moves faster, it needs more energy to keep accelerating. When it gets close to the speed of light, the energy requirements skyrockets. To hit light speed, you'd need infinite energy, and that's just impossible. But wait, there's more. At super high speeds, time itself starts to slow down for the moving object. This means light speed stays constant no matter how fast you're going. Crazy, right? This speed limit applies to everything with mass. But light, which is made of massless photons, can hit this max speed. Anything faster? Nope, not happening. So, next time you see light zip by, remember, it's moving at the ultimate cosmic speed limit. Einstein's got our backs on this one. Catch you next time for more mind-blowing science facts. Ever wondered what powers the sun? Let's talk nuclear fusion. Nuclear fusion is when light atomic nuclei, usually hydrogen isotopes, merge under extreme pressure and high temperatures. This process releases an enormous amount of energy. Sounds complex, right? Let's break it down. Imagine two hydrogen atoms. They collide with such force that they fuse into a helium atom. In the sun, this happens millions of times every second. The magic? The helium nucleus has slightly less mass than the original hydrogen nuclei. That missing mass turns into pure energy thanks to Einstein's famous formula E = mc². Fusion powers stars like our sun and could be Earth's ticket to clean, almost limitless energy. But here's the catch: replicating those extreme conditions, millions of degrees and immense pressure, is super tough. Scientists are working hard to make this dream a reality. If we crack the code, fusion could revolutionize how we power our planet. So next time you see the sun, remember, it's not just a ball of fire. It's a giant fusion reactor. Stay curious and keep looking up.
Am I the only one that didn't know the universe is expanding? Mind-blowing, right? Since the Big Bang, around 13.8 billion years ago, the universe has been expanding in every direction. This idea got a huge boost in the 1920s thanks to astronomer Edwin Hubble. He discovered that galaxies are moving away from each other. But here's the twist: it's not that galaxies are cruising through space like cars on a highway. Nope. The space between them is actually stretching. Imagine blowing up a balloon. As the balloon gets bigger, every point on its surface moves farther apart. That's our universe. The galaxies aren't moving on their own. Space itself is expanding, carrying them along. So next time you look up at the night sky, remember, it's not just big, it's getting bigger. And that, my friends, is why the universe keeps expanding. Stay curious. Smash that like button and follow for more cosmic wonders. If your idea of a wild event is a star exploding, you're about to be amazed. Picture this: a massive star reaches the end of its life and explodes in a supernova. The core of this star collapses under gravity, squeezing atoms so tightly that only neutrons are left. This creates a neutron star, an insanely dense object. How dense, you ask? Just a teaspoon of neutron star material would weigh as much as a mountain. Despite being only about 20 kilometers in diameter, a neutron star packs more mass than our sun. Imagine all that mass crammed into such a small space, and it doesn't stop there. Neutron stars have insanely strong gravity and spin super fast, making them some of the most extreme objects in the universe. Crazy, right? So the next time you look up at the stars, remember, some of them are living on the edge of cosmic insanity.
What's something people don't know about the universe? It all started with an epic event called the Big Bang. Around 13.8 billion years ago, the universe was born from an unbelievably small, dense, and hot point. But don't think of it as a regular explosion. Instead, it expanded at an astonishing speed. In mere seconds, the building blocks of matter, like protons and neutrons, started to form. These particles eventually came together to create atoms. As the universe continued to expand and cool, it paved the way for the formation of stars, galaxies, and planets. The Big Bang wasn't just an explosion, it was the birth of space, time, and everything we know. So next time you look up at the stars, remember, you're gazing at the remnants of the greatest cosmic event ever.
The universe holds many secrets, but why is it so dark? The universe appears black because space is mostly empty with very few light sources. Stars and galaxies do shine brightly, but their light often doesn't reach us. Why? First, they're incredibly far away. Second, light is absorbed by dust and gas. And third, the universe is expanding. This expansion stretches light from distant objects into longer, invisible wavelengths like infrared or microwaves. So even though the cosmos is filled with brilliant stars, we mostly see darkness. There's just not enough light hitting our eyes. Next time you gaze into the night sky, remember, it's not empty darkness. It's a universe full of distant, hidden light. Stay curious, space enthusiasts.
This is why you need to know about quasars. These cosmic lighthouses are lighting up our understanding of the universe. A quasar is the extremely bright and energetic core of a distant galaxy. At the heart of these galaxies lies a supermassive black hole. Gas and matter fall into this black hole, get accelerated to incredible speeds, and heat up. This process releases massive amounts of light and radiation. So much light, in fact, that a single quasar can outshine all the stars in its galaxy combined. And get this, they're so bright we can see them from billions of light years away. Quasars are the universe's lighthouses, beaming clues about the early days of galaxy formation straight to us. Fascinating, right? So next time you look up at the night sky, remember, those tiny specks could be the brightest beacons of the cosmos. Keep exploring, keep wondering, and keep looking up.
You need to watch this if you struggle with sunscreen addiction. Meet the unsung hero of our atmosphere, the ozone layer. This thin shield floating 15 to 35 kilometers above us is packed with a gas called ozone, or O3. But what makes it so special? Ozone acts like Earth's very own pair of sunglasses, absorbing harmful UV radiation from the sun. Without it, think skin cancer, eye damage, and even messed up ecosystems. The ozone layer filters out most of this deadly UV radiation, keeping life on Earth safe and sound. Imagine a world where stepping outside could be deadly. That's why we can't live without the ozone layer. It's invisible, but its impact is crystal clear. So next time you look up, give a nod to the ozone layer, our silent protector. Curious for more? Hit that follow button.
Why are there not more people talking about Saturn's rings? Time to uncover the secrets of these cosmic wonders. Imagine billions of icy and rocky particles all dancing around Saturn like tiny moons. That's what Saturn's rings are made of. These particles range from tiny dust specks to massive chunks several meters across. Each one orbits Saturn, creating a mesmerizing cosmic ballet. But here's the kicker. Despite spanning an incredible 280,000 kilometers, the rings are super thin, just a few meters thick. How cool is that? Scientists believe they might be remnants of moons or comets that got too close and were torn apart by Saturn's powerful gravity. These rings make Saturn one of the most striking planets in our solar system, so next time you gaze up at the stars, remember the stunning, delicate rings of Saturn. They're a reminder of the beauty and mystery of our vast universe. Stay curious, space lovers, and don't forget to hit that like button if you learned something new today.
Ready to have your mind blown? Let's talk moon origins. Around 4.5 billion years ago, our young Earth had a colossal crash with a Mars-sized object. Boom! This massive collision sent a ton of material flying into space. But wait, it gets better. This space debris started to gather thanks to Earth's gravity, forming a giant disk around our planet. Over time, this debris clumped together and voila, the moon was born. This epic tale is known as the giant impact hypothesis. And it's why the moon has been Earth's loyal sidekick ever since. So next time you gaze up at that glowing orb in the night sky, remember, it's the result of one of the most dramatic events in our planet's history. The moon, born from chaos, has been lighting up our nights for billions of years. Stay curious, space lovers.
Why do 24 time zones split our planet into different times of day? Let's find out. The Earth spins once on its axis every 24 hours. That means at any given moment, different parts of the world experience different times of day. To manage this, we divided the Earth into 24 time zones. Each time zone covers about 15 degrees of longitude. Why 15 degrees? Well, because 360 degrees divided by 24 hours equals 15 degrees per hour. This keeps the sun's position roughly the same for each zone, so when it's noon in New York, it's already evening in London. This system helps us coordinate activities globally and avoids chaos. Imagine trying to schedule a call without time zones. Next time you check your watch, remember, it's not just about the numbers, it's about where you are on this spinning planet. The mystery of time zones, solved. Stay curious, my friends.